All right, so section 5.4, we're going to talk about a couple different things in this section involving radical functions. So the first thing we're going to do is the domain of functions that involve roots. So we're going to divide this into two parts. The first part is what happens if the index is even. Now, in case you don't remember that term, the index refers to what kind of root you're taking. So in this case, this is a square root. The index is 2. We don't tend to write the 2. This is a fourth root. Both of those are even numbers. So what do I do in that situation? So I just want to refresh your memory, go back to our basic square root graph, which I have right here. So on this board, I've got our basic square root graph. Notice it starts at 0. It has a limited domain, and the domain of this is from 0 to infinity, and we have talked about that extensively when we talked about our basic functions. So we're going to use that fact to find the domain of these. So if, according to my basic function, according to the graph we just looked at, if what I'm taking the square root of has to be bigger than or equal to 0, because that's the only place the graph exists, then what I'm going to do to find the domain is I'm going to take the thing under the radical, which is called the radicand, and I'm going to take it 3x minus 5 and say that has to be bigger than or equal to 0. And I'm going to solve this inequality. I'm going to add 5 to both sides and get 3x is bigger than or equal to 5. I'm going to divide both sides by 3 and get x has to be bigger than or equal to 5 over 3. I'm now going to write that in interval notation. So what this says is all the values I can plug in, all of the x's, have to be bigger than or equal to 5/3. What that does is it makes 5/3 the lower bound of my interval, so 5/3. Since there's an equals, I'm going to put a bracket there. And since there's no upper bound, I'm going to use an infinity. So there is my domain of the square root. So what I recommend you do is pause the video and find the domain of the fourth root of 7 minus 4x. Then press play and watch me do what hopefully you're about to do. Welcome back. And so now I'm going to take the 7 minus 4x. That has to be bigger than or equal to 0. Any even index, 2 or 4, 6, 8, 10, whatever the index is. So here I'm going to subtract the 7 from both sides. I'm going to divide both sides by negative 4. Negative 7 divided by negative 4 is a positive 7/4. And then remember, when you divide both sides of an inequality by a negative, you have to flip that inequality sign so it becomes a less than or equal to. So now all of the values I can plug in are less than or equal to 7 over 4. And so that means now 7 over 4 is an upper bound, and that my lower bound is negative infinity. I'm going to put a bracket here because I have an equals. We always use a parenthesis with our infinity. So that is type 1 when I have an even index. The second situation is what do I do when I have an odd index? Now, while I'm erasing the board, maybe you go through your notes, you find your basic graph for the cube root function. So the second situation is if I have an odd index. And if you remember your cube root function, it has no limit on the domain. We saw back at the time when we graphed it that it went as far left as you go, so negative infinity, and as far right as you can go, so positive infinity. And so if I have a function with an odd index, whether it's a cube root or a fifth root, so if I have the cube root of 7x plus 19, and then g of x is maybe the fifth root of 2x plus 9, well then since my index is odd, there is no limitation on the domain. I can take the cube root of any number at all. Use your calculator to see that. So what is the domain? The domain of this is just negative infinity to positive infinity. There's no calculation to do. So once again, push pause on the video and find the domain of this. I'm going to give you 5 seconds to do it. And now I'm back. And so the domain of this, because the index is odd, it's a 5, it is negative infinity to positive infinity. Just that quick and easy.